Hello, class. How are you doing? Let me set up the window that we're going to use and let's go ahead and get started. Okay, let's talk about correlational research. Okay, correlational research, before we begin, is a type of research. I haven't done really many correlational research studies, but generally, correlational research is done a lot by practitioners. And it's a lot of times a precursor to experimental studies when you don't want to spend the time or don't have the time or the money to do a full-blown experimental study. People usually do correlational studies to test whether there is a relationship between a variable. Say, for example, you started an after-school program. Is that after-school program having some type of effect? By effect, I mean, is it making kids more civic-minded? Well, how would you know that? You would have to operationalize the variable civic-mindedness and measure it with after school amount of participation in after school programs to see if there's a relationship. And that's really why this type of research is done. And so what we're going to do is we're going to go through some of the basics and overview of the research to see if there are any questions at the end. Okay, I'm not tapping there. Let me tap over here. Okay, sorry, I got three screens going here. Okay, so what is the purpose and definition of correlational research? As I said earlier, it involves collecting data to determining whether and to what degree a relationship exists between two or more quantifiable variables. And the variables in this case, for example, let's use membership in a gang. If you're a membership in a gang and how much of a membership, are you a strong member, such as like a gang leader, or maybe you're a weak member? You just maybe like to hang out with gang members, because they live in your neighborhood or whatever, right? Level of degreeness of gang membership with academic studies, how good you do in school. That would be an interesting study to do, right? Because it would be a good sort of reason to deter, right? Kids that want to do good in school, you say, well, we have data that shows that if you want to do good in school, you need to sort of keep your distance from the gangs, right? Don't get involved with gangs, that sort of thing. Another may be, level of, drugs, right? Are you drinking? Are you smoking? Level of time spent doing homework, all of those things, amount of time spent in class, okay? And so the purpose is to determine whether there is a relationship, right? You can't always just assume that there was a relationship. Sometimes if you're in schools, and I'm using school examples because a lot of the students, do end up working in schools in some way, shape, or form, right? And so in a school, sometimes if you're a school leader, you may make assumptions about, hey, I know that this kid's going to do well because I know that their parents are involved in school. Well, that may be maybe a traditional view of who does well in school, but it may not be an updated view, or it may not be something that is supported by the research. And then thus, that's why we may want to sort of engage and do correlational studies to confirm any type of preconceived notions or stereotypes that we may have about the students that we serve. And also to use relationships among variables to make predictions, such as, okay, I want to know, the more time students spend, studying math in the math club, the more likely they are to take the math AP exam and succeed. Can you measure that relationship? Can you make a prediction? If you do a study that shows that there is a relationship, it's a quick way to make a prediction for success in any type of exam, if that's what you were looking at. And to note, the high variable correlation does not imply that there is a cause-effect relationship, but does allow for prediction of the relationships, okay? Sometimes there may be extenuating or external or additional variables that may be impacting what you're looking at, and it may have nothing to do with the relationship that you're looking at. One example may be, well, that you measure the degrees every day in school, and the hotter it gets, the more likely there are to be fights. Well, everybody sort of knows that. Those studies have been done. We know that there are more fights in, particularly high school, the hotter the day gets, right? But there may be other things happening that you don't know about. Maybe there's a gang war going on in your turf, other things that maybe impacting that relationship that you may or may not be aware of, and all you may just think it's the weather. It just happened that there was some sort of gang war at the same time that it started getting hot, right? And you knew about one, but you didn't know about the other. That's really what it means. But it doesn't mean that there is reason for predicting that one thing is going to lead to the other. Okay, so the first thing you do, you select the problem. You should have a rationale for your selection. You should have a logic that is derived from theory or experience. So let's say for me, like I want to study gangs. Okay, I want to study gangs and how gang membership affects academic success. Okay, so that's the thing that I'm looking at. Why? Do I want to study it just because I've written on gangs before or anything like that? Probably not. You should probably be studying that issue if you know that there's maybe a lot of gang activity in the community surrounding your school or things of that nature, right? You should have a rationale for selecting that problem. So here are some examples of maybe good or bad examples. So there's a correlation between getting good grades in high school and getting good grades in college, right? Because I have college students that came back and that I work in the high school and they told me they're doing really well, and I know when they were here they did very well. Now maybe there's a strong correlation. The rationale for it, or the reason for why you may believe that may not be strong, right? Knowing because you have some select students that told you, but definitely there's always going to be a correlation between high school GPA and college GPA. There's a correlation between being in a gang and dropping out of school because everyone knows gang members are not interested in doing well in school. Perhaps there is a correlation. The only problem that you're going to run into here is when you do have select amount of gang members, very few that maybe are interested in school. And for one example, and this may be an anomaly, but I don't know if you've all seen the movie Stand and Deliver. You all can watch it. I believe Tubi has it for free, and you can watch it there about a school in Los Angeles, right? That the schools, at Garfield High School, a bunch of the kids passed the AP exam. It's based on a true story, and except there was one kid, Lou Diamond Phillips. I don't know if you know him, that was a gang member, but also wanted to do well in school, and actually did well in school, right? So you do have those type of anomalies, and that's the problem with applying this type of using the research on this correlation, to be able to do sort of blanket overriding predictions of what's going on in your school, and maybe giving up on all the kids that may be gang members or the like, right? And a correlation between being a good chess player and doing well in school, because I play chess and it makes me think a lot, right? It's based on your own personal preference. There could very well be a correlation, right? But the fact that you really don't have anything that helps you make a prediction or an understanding of the issue other than your own personal experience. And again, not that we want to discount your personal experience. It's just that may not be enough to really be able to say this is what I want to study. Okay. All right. So participants, the key thing about correlational studies is you have to have at least 30 participants in order to have some level of validity in the studies, and to be able to really say that, okay, this is a worthwhile study. The data that I have is good. It's enough for me to understand the issue to a greater degree than what I presently understand it. And then you also have to measure validity and reliability, which we've talked about in other sessions and we'll continue to talk about, to really truly understand the correlation between these variables. And again, validity and reliability are both important, but just because you have validity doesn't mean you have reliability, and vice versa. Okay. All right. The design. How do you design a correlational study? What are the procedures? First of all, you got to select the groups. Let's stick to my example. Well, maybe the gang member example isn't good because maybe there aren't that many, gang members in the school. But let's say, kids that are in the chess club. Okay, maybe in my school, there's a lot of kids in the chess club. Okay, you want to select kids that are maybe in the chess club, right? That may be one group. You get 30 of them. There's a lot. You got to have at least 30, and then maybe kids that are not in the chess club. And then you want to study how well they do, maybe like in geometry, right? Because that's the good thing. One thing about chess is it develops your spatial intelligence, similar to geometry. Kids that are good at geometry have good spatial intelligence. Or if you don't have spatial intelligence, geometry helps you develop spatial intelligence. And spatial intelligence is good for fields such as, maybe mechanical engineer or a different type of engineering field, that type of thing, right? So, okay, selecting group, selecting the independent variable, deploying the surveys, right? What type of questions are you going to ask? Collecting the data, analyzing it, and comparing both of the groups. Okay, I have 30 kids from the chess club, 30 kids that were not in the chess club. How do I compare them? What are the results in terms of, their grades in geometry class, for example? Okay, and then you report a correlation coefficient, which we're going to talk about shortly here. What does that mean to report a correlation coefficient? Okay, there are 3 types of correlation coefficients that we want to focus on. Okay, there's a correlation coefficient that can have a very strong positive relationship, very strong negative relationship, and maybe weak or no relationship. So we're going to look at all 3 of those. This is the way that you read those. A very strong positive relationship is going to be -1. Actually, sorry, that's going to be +1. Okay, we'll change it later. And a very weak relationship is going to be -1. No relationship is going to be 0. All right, so let's look at that in more detail. Okay, here it is. Okay, so the first, as we're looking at this table, let's look at the first 2 columns. Here we have 8 students. Obviously, you need 30 or more students, but just for sake of being able to fit it on the page, let's focus on 8 students. We have 8 students. The first 2 columns are going to say that we have a strong positive relationship. Okay, that means that we have a strong correlation here. Okay, strong relationship between IQ and GPA. The higher the IQ, the higher the GPA. The relationship, the coefficient here in the bottom, R equals +95. If you look at your little legend on the left, strong correlation is between 0.65 and +1. Right? That's really close to the +1, almost a perfect relationship, extremely predictable. The higher the IQ, the higher the GPA, almost without fault, there's going to be a positive, strong correlation. Okay. Now, the next 2 columns are IQ. You still have the same variable IQ, and then you have weight. How much do kids weigh? Right? Perhaps some people believe, oh, well, the kids are out of shape, they're lazy, and maybe they don't do too well, or maybe they're not too smart. And the research shows, at least in this table, that there is absolutely no relationship. You can have one kid that is 300 pounds and one kid that is 150 pounds, and that is going to have no effect on their IQ. Right? You can have the smartest kid in the school could be, the skinniest kid or the fattest kid in the school. It doesn't matter. There is absolutely no relationship at the bottom. The relationship is +13. Which means, what does that mean? Very weak relationship. A plus or a -35 is mean that there is weak relationship to no relationship. You can never look at somebody's weight and determine their IQ or even try to predict IQ. Okay. And then you have a strong negative relationship in the last 6 columns, which is how many errors a kid, a kid has on an exam, right? And as you see here, there's a very strong correlation, right? The higher the IQ, right? If a kid has extremely high IQ, they probably don't even need to study and usually still ace the exams, right? But the lower the IQ, the more errors are going to be on the exam. And this almost without fault with a 0.89, but it's negative 0.89 correlation, meaning the higher the IQ, the lower the errors on an exam that you're going to have. So that means you have a very strong negative correlation. Not as strong as the GPA one, but very, very close to it. Okay. And that's what you determine. That's how you determine, is one going up and the other going down. And there's a good prediction of those 2, or one going up and the other one going up, whether you have a positive, negative correlation or no relation. Okay. All right. So then you have the relationship studies, where you have the purposes to attempt to gain insight into the variables or factors that are related to the complex variables such as academic achievement, student success, after school success, anything that you want to measure that you think is worthwhile that's going to help you to expand those programs or to invest more money and resource in the programs that truly help students. Okay. And also to help researchers identify, related variables that are suitable for examination, or to make, or to, evoke, or to start causal comparative or experimental studies. Okay. Many times relationship studies are precursors to experimental studies, as I said earlier, and people do the relationship studies because they cost less time, less money, and it's a good justification for say, hey, we know that there's a relationship. Now let's go ahead and develop the more elaborate, the more costly experimental study to make sure that what we're finding here is truly going to help us improve our school. Okay. Data collection and relationship studies, you identify the variables that you're going to study. You identify the population or populations, right? Well, population in this case would be chess players, or people that are in after school programs or in clubs, or the population may be the kids at the school, and then the different groups, the samples, may be chess playing kids and non-chess playing kids. You have a plan for data collection, when you're going to collect it, how you're going to collect it. Data, you have the data, the actual data collection. You have the variable correlation to understand the relationship between two groups or two variables. You eliminate variables that have little relationship, that are only going to complicate your study, right? And really have no meaning to the study. Really don't have any don't show any type of relationship. And then you select the variables with with the highest relationship for further investigation, or to do again the more elaborate experimental study. Okay. When you do data analysis and interpretation, once you have all the data, this is when you're comparing the scores between two or more variables. You're going to compare in one group the relationship between playing chess and succeeding in geometry, and not playing chess and succeeding in geometry. You're going to either have a Pearson R, right, which is the most common type of relationship. That's the one we looked at earlier on the example with the GPA and the IQ, right? But you have to have a population of more than 30, okay, which we didn't show you. I just showed you 8. Or you have a rank differentiation correlation, which usually measures a relationship. The comparison of the variables are rank or ordinal, right? Rank means something like IQ measurement, where they're not going up like they're going up in the you can measure the relationship, the difference between each one of those variables, and you can see exactly how different the relationship is, the size of the relationship, the size of the difference. Okay. And then you have the pi coefficient when variables are dichotomous, such as male, female, true, false. Maybe you want to measure, which people don't do these studies, but whether being a male is whether males are more likely to succeed in algebra 1 or females, right? I mean, not that you wouldn't do those studies to say, okay, I see males are better. You may want to do that study to say, okay, maybe the females aren't doing too good. Maybe we need to invest more money in really helping females with algebra, as we're not doing too well in our school. That's the reason you might want to do one of those type of studies. Okay. All right. If two variables, then you have prediction studies. These are a different type of study. Okay. These help one of the variables predict the other, right? This is when two variables are very highly related. The score on one can predict the score on another. So here are just some examples here, right? Generally, anybody who has high school grades is going to have good college grades. Not in every situation. Okay, when I was in high school, one kid that was valedictorian ended up going to college and didn't do very well, not because he wasn't smart, because he wasn't really trying. He was busy doing other things. He had his life going. I think he had gotten married and done other stuff, right? But generally, in most cases, one is going to predict the other. Buying a hamburger and buying fries. I learned this in a business class that I took, right? Almost all places, the hamburger may be cheap, but the fries are really expensive, because they know almost nobody buys a hamburger without buying fries. It's almost, there's a very high chance that one is going to predict the other, right? Or you go to, I know we like to go to, um, what is it? Spaghetti Factory. It's one of our favorite restaurants. I have a young daughter, and the meal may not be too expensive, but then you get the drink, the cotton drink or whatever, the kind of stuff the kids drink, and that thing is almost as much as the meal, right? Because they know, hey, the kid's gonna want some type of fancy drink or whatever, and this is really where something that their parents can't deny them that drink, and this is really where we make our money. Or when you go and you go to a hamburger place and the soda, right? The soda only costs like 5 cents to make, and it may cost $5 or something for the soda, right? They know if you buy a hamburger and fries, you're probably going to buy a soda. Buying movie tickets and buying popcorn. I don't buy popcorn when I go to the movie theater, but only because I know that they're expecting me to buy popcorn, right? Sometimes the popcorn's more than the movie theater ticket, right? Because they know we've all been socialized, and even when you start watching the movie, the first commercial is a big bag of popcorn, and they're really testing your taste buds so that you could really go buy that bag of popcorn. They know that's where they make their money, right? Being in a gang and committing crime, dropping out of school, or having low lifetime income, or passing algebra and having success in college. All of those things have been studied and know that there is a relationship between them. One can predict the other. Okay. All right. Prediction studies, you got to identify the sample. You got to select the measuring instruments being the survey or that type of thing, identifying the terms for predictor or complex variables that you're going to use, collecting the predictor variable data, making the actual prediction, waiting, assessing your accuracy of your prediction, and if you're accurate, replicating the prediction with other groups to have cross validation to make sure that there are no variables that are polluting or affecting the relationship between the two variables that I'm studying to make a prediction. You want to make other cross validation to make sure that you're truly absolutely correct in what you're going to be predicting here, and how you're going to maybe perhaps change a school or invest funds in one program or another. The data analysis and interpretation most use this formula that x equals a plus bx. Y equals a plus bx. So you have the prediction criteria equals the constant calculated from all the scores, right? You add up all the scores plus the coefficient. What is the coefficient? Times multiplied by the individual scores. Okay. Intervening variables are variables that give way, that get in the way, that affect reliability. If you wait too long before collecting predictor variable data and complex variable data. Okay, now you have the effect of history that is affecting your study, and you make sure that history, as something that's going to pollute your study, you want to be able to collect that data. You might not want to wait too long before you collect all your data. Okay. All right, the problems to consider in interpreting the correlation coefficients. You may have the wrong correlation methods that are being used to calculate the correlation, right? You may think you're using the right methods that maybe methods that are have low validity or things of that nature. Regardless of the case, you may have really the wrong correlation methods that are using. You have unreliable variables, right? You think that you're measuring kids in the chess club, but the ones that took your survey, they just joined the chess club yesterday, right? It's they're not really chess club kids. They're in the chess club, but they don't really have any history in the chess club, right? And so your variables may be unreliable there. Weak validity of variables, right? One isn't really predicting the other, and you don't know why, or one is predicting the other, but it shouldn't predict the other, right? There may be no relationship, like say, for example, IQ and somebody's weight, right? You have a narrow, restricted scores that are correlated, or you have a small sample size. Remember, in correlation studies and in prediction studies, you want a sample of at least 30 students per group If you're doing more than one group, you want at least 30 per group. Okay. And that's going to go ahead and end the lecture. Thank you very much. And I look forward to hearing from you later on. Thank you.